Okay, here we're trying to write down the nth term of the sequence. So we can see that it's 6 to 13 is 7, 13 to 20 is 7, and 20 to 27 is 7. So we definitely know the common difference is 7. So we've got 7n. Then thinking about the 7 times table, if we just had this as our formula, it would be 7, 14, 21, etc. And we can see that the sequence we wanted is actually 1 down from that. So we've just got to subtract 1 off of each term. Next one down, it's gone down by 6, down by 6, and down by 6. So that must be our common difference, so minus 6n. And then we would have minus 6, minus 12, minus 18 as that sequence so far. So we're looking to see what do we have to do to get from this sequence up to that one. So we're obviously adding on quite a bit there, and it's 32 that we're adding on. Okay, now this question is actually beyond the scope of the course so far, but you can have a look now to see how you do it anyway. You will have covered this in Year 9. So first of all, we're asked to find the total number of tiles in pattern N. So if you have a look at the width of each one, the width of every pattern is twice as big as the number of pattern it is. So pattern 1 is 2 wide, pattern 2 is 4 wide, pattern 3 is 6 wide. So the widths go up in 2n. Because we know what the area of a square is, it's going to be base times height, and as it's a square they're both the same, the total tiles will just be 2n times 2n. And simplifying that gives us 4n squared. Right, now onto the grey tiles. That's going to be a little bit more complicated. So let's look at the greys and let's count them up. So in pattern 1 we've got 3. In pattern 2 there are 9, and in pattern 3 there are 19. Looking at those common differences, it's 6 and then 10. So it's not going to be a standard formula, we can see that straight away. So what we need to do instead is look at the difference between the differences, so we call that the second difference, and that's 4. Right, now there's a rule for using that second difference to finding the number of n squareds involved, and you half it, that's the rule. So to get from the second difference the number of n squareds, we're going to divide by 2, and that's going to give us 2n squared. So we know that 2n squared is part of our formula. So what I'm going to do now is I'm going to rewrite out my original 3, 9 and 19. And so that's my actual pattern, and I know that 2n squared is involved. So what I'm going to do next is see what the 2n squared sequence would look like. So remember, n is always 1 for the first term. 1 squared times 2 would be 2. 2 squared times 2 would be 8. And then 3 squared times 2 would be 18. So that's the 2n squared bit. I'm just going to subtract that off, and so that then I can just look at what the remainder is going to be. So actually the remainder each time is just 1. So all I need to do to get from the 2n squared that I have so far up to the sequence that I wanted is add on 1 each time. So that means that my final rule for the greys is going to be 2n squared plus 1. Right, now we might have to go through that same process again to get the white ones, but there's a little bit of a trick that we can use, because we know that the grey plus the white has to equal the total. So to get the white, all we need to do is do the total number of tiles, 4n squared, and then subtract the grey, so 2n squared minus 1, so it's minusing everything, and that's going to give me 2n squared minus 1 for the white. Again, this isn't in the syllabus so far, so we can cover it again at a future date.